Hi guys, there are a couple of questions from section 1.7. The first one is number 13, should be a quick one. So we are asked to differentiate to find the derivative, and our function is y equals 1 over 4x plus 5 all raised to the second power, or also known as the square. So obviously this is a section that they introduce you to chain rule. So really most of the problem that I think I assigned, you need to use one of the consequence of chain rule, which is called the extended power rule. So the rule is actually pretty straight. It says that if you differentiate any function raised to a power, so this is the derivative of a function to a power. That's why they call it extended power rule, because you're raising a function to a power, not just because we learned how to differentiate x to a power, but this is a function to a power. That's why they call it extended power rule. So basically the rule says you bring the power down, multiply by the function itself, and then raise to the power, whatever the power was, minus 1, and then times, and this is a part that a lot of the students forget, times the derivative of the function that is being raised to a power. So we're just going to use f prime, which is the notation for derivative, right? F prime of x. So this is, I believe this is on your textbook. If you look on page 169, this is theorem number 10. It's called the extended power rule, okay? So I mean, they may use different letters, but this is the concept. Anytime you differentiate a function to a power, the rule says you bring the power times the function to the power minus 1, and then times it to the function. Obviously, we do have a quotient here, but I would not suggest you use quotient rule, even though we learned that in section 1.5. I'm going to actually do a little algebra here to help us cut down our work, okay? I'm just going to move this upstairs. As you remember in algebra, anytime you move something from downstairs to upstairs with the exponent, all you got to do is change the sign of the exponent. So it's the same thing, it's just a different way of writing it. Now, the good thing is once you write it like that, you can just go straight to the extended power rule. That says the derivative, which is called y prime or dy dx, whatever notation you want to use. So this is your power, this is your function. So this will be like your f of x, negative 2 will be your n. So as you apply the property, you bring the power down times the function itself, which is 4x plus 5, raised to the power minus 1. And then don't forget the last part, times the derivative of the function. Our function, of course, is 4x plus 5, and its derivative, of course, is simply 4. So I'm just going to clean up a little bit, but that's pretty much your derivative. 4 times negative 2 is negative 8. Minus 2 minus 1 become minus 3. Actually, you could leave your answer like that, but sometime in math, they don't like to see negative exponents. So if you want to move that downstairs, you can actually rewrite that as negative 8. Again, if you remove it from upstairs to downstairs, you change the sign, also vice versa. Downstairs to upstairs, you change the sign. Either way, that's the rule from an exponent from algebra. If you move it back to downstairs, that becomes 4x plus 5 cubed. So we just change the power from negative 3 to plus. So that's what happened when you move something. Now, you could have kept it with a negative exponent, but most of the time, the back of the book, usually don't like to leave it as a negative exponent. So that should be your derivative, okay? So I'm going to stop this video, make another one, because there's another question. But if I put them both in the same video, it may be too long, okay?